Hi, my name is José Manuel Crego Lozares and I'm a research associate under the REDI program, hosted at Technological University of Hamburg and Royal Melbourne Institute of Technology in Australia. Recent advances in well-renowned metal additive manufacturing, commonly referred to as 3D printing, have enabled the selective deposition of materials, which means that we can now create custom parts with distinct alloy regions. Having access to a catalog of different material properties, combined with the benefits from additive manufacturing, allows us to create multifunctional complex designs, which directly translates into superior performance delivery. My research focuses on overcoming the chemical and physical barriers that appear when printing a copper-based alloy next to a nickel-based alloy, combination intended for extreme heat dissipation and maintaining structural integrity. Defects such as cracks, sink rates, and undesired compounds might appear during the 3D printing process as a result of the mismatch in thermal properties, chemical incompatibility, and de-optimized printing parameters for the desired arrangement of materials in the 3D space. My approach relies on the identification of laser configuration that minimizes the material mixing and elimination of defects, and also the identification of a heat treatment route that guarantees the required mechanical properties and microstructure for our application. The desired use case of application for this project is a bimetallic combustion chamber from the newest era of rocket engines, where this technology can dramatically reduce the process chain and reduce the cost and leading times by up to 60%. But this is not only for rocket science lovers. By solving fundamental material science questions, we can unlock new design possibilities across industries, with aerospace at the forefront of this groundbreaking change. Let's work together to make this a reality.